Hello everyone, this is the notes on selection sort for AP Computer Science. So the challenge we want to undertake today that's going to help teach us about selection sort is this one. So I've already written a tester class that's available on the website. What you're going to have to do is copy and paste that into Eclipse. You'd have to make a new Java project for that. So the tester class that I wrote already includes a main method that declares 3 different integer arrays. For each array, I call the ssort method, which is going to use selection sort to put each array in order from least to greatest. What I didn't do is give you the ssort method. You're going to have to write that yourself. So when you compile and run after you've written your ssort method, the console at the bottom is going to tell you, it's going to give you the arrays that you've sorted, and it's going to tell you if it's right or wrong for each array. So you have to use selection sort. So what is selection sort? Well, a selection sort, and I'm going to show you the algorithm for that, show you how it works in just a second, but in order to do it, the preview is you have to use 2 loops. The first loop the outer loop is going to work through the array and is going to select each number that we're going to fill in. The inner loop, after you've selected the first number, is going to find the lowest number in the array and then put it in that selected space. So here's what that looks like in practice. This is the array that I'm going to sort. I'm going to have gray numbers are going to be boxed in, or the gray boxes mean the numbers have not been sorted yet. So here's the numbers I have: 15, 12, 73, 34, 8, 44, 61, and 88. Obviously that is an unsorted array. So I'm going to have 2 arrows on here. One's going to indicate the index. I'm also going to have a little box on the value bottom that's going to hold our minimum value. That's going to be a variable that you're going to need in this method. So pass 1, I'm going to have an outer loop. It's going to hold my selected index. That's the index that I'm trying to fill with the lowest number in the array. The green arrow is going to represent the outer for loop. The inner for loop is going to be represented by a red arrow. So every time the outer loop does not increment until the inner loop finishes. And I'm also going to have a marker that's going to mark which index is my current minimum number. Because it's not just enough that I know the minimum value, I have to also know where it is. And you'll see why in a second. So in the first pass, the first iteration of the outer loop, I'm going to start running the inner loop. Right now, the minimum value, which I put in the yellow box at the bottom, is 15. So I go to the next number and I decide, well, is the number I'm pointing to less than the current minimum value? And the answer there is yes. So that means I do 2 things. I move my minimum marker to that index, and I change the value of minimum value to match the number in the box. I iterate the inner loop again, and I get to 73, which is not smaller than 12, so I just move on. 34 is not smaller than 12, so I just move on. 8 is smaller than 12, which means I move my minimum marker to that index where the 8 is, which is index 5, and I change my minimum value to 8. Keep going. 44 is not less than 8. 61 is not less than 8. 88 is not less than 8. Okay, now I've gone the rest of the way through I'm on the last index of the array. So I'm going to stop inner loop and I'm going to go ahead and switch the values up. So the first thing I'm going to do is I'm going to take the number that is in the selected index, in this case index 0, and I'm going to move it to where the minimum value was. Now I don't have to worry about losing that number because I already have it down at the bottom right where I have my minimum value in the yellow box. So I'm going to take that minimum value and move it into the selected index. So now that that first number has been sorted, I'm going to make it white, and then my outer loop is going to iterate to the next index. When that happens, inner loop resets, and so does the minimum. And in this case, the minimum value is 12. Then the inner loop goes to the next index. 73 is not less than 12. 34 is not less than 12. 15 is not less than 12. 44 is not less than 12. 61 is greater than 12. And 88 is greater than 12. So that means I take away the 12 and replace it with the minimum value 12, which basically means nothing happened. Then that one's sorted. My outer loop goes to the next index, and I reset minimum and inner. In this case, right when I start, the minimum value is 73 because that's the only value that inner has seen so far. I go to the next index, That's 34, which is less than 73, so I move my minimum marker. I change the minimum value to match the number that's in that marker, where that marker is. And I go to the next number. Now I have 15. 15 is less than 34. So move the minimum marker, change the minimum value, and then go on to the next. 44 is greater than 15. 61 is greater than 15. 88 is greater than 15. So the biggest number that's left, the smallest number that's left, is 15. So I move the number that's in my selected index to where the minimum is, and then I move the minimum value into the selected index. Turn it white because it's been sorted, and that means I move my outer to the next number. Reset inner and minimum again. So the minimum value is 34. The minimum marker is where the inner is, and I start moving. 73 is greater than 34, so I do nothing. 44 is greater than 34, so I do nothing. 61 is greater than 34, so I do nothing. 88 is greater than 34, so I do nothing. So what I can do is I can move the selected value to the minimum index, which means it doesn't move. Then I can replace the selected value with the minimum value, and the 34 stays where it was. That one's been sorted. Go to the next number, and that means inner resets. So the minimum value so far is 73. Move to the next index. 44 is less than 73, so I move the marker and change the minimum value. 61 is greater than 44. 88 is greater than 34. So the lowest number I have of what's left is 44. So I move 73, marker, because that was in the selected index, to 44. Move the minimum value into the selected index, and I've sorted the next number. Now I reset again after I moved outer up. 73 is my minimum value. 61 is less than 73, so I move the minimum, change the minimum value. 88 is greater than 61, so I do nothing. That means I can move 73 to where the minimum is, move the minimum value into the selected index, and then increment the outer loop again. Once I increment, it resets. So now everything's reset. I have a minimum value, my minimum, my inner, all set. Move to the next index. 88 is greater than 73, which means I'm going to end up putting 73 right at the selected index. Increment it one more time to get to pass 8. Once I'm at pass 8, I have the minimum value is 88. There's nothing else for me to check, which means I can just move the minimum value up into the 88, and that one's been sorted. So that's the way selection sort works. You're just basically going through each index one at a time of the array and finding out what the lowest number left after that one is. Because once you pass it, you know where you have the lowest number has already been accounted for, and you keep doing that until there's no more numbers, no more indexes to figure out, and that'll give you a sorted array.